Hello, statistical superfans. This is Mr. Schneider coming at you with example 3. Let's see, we're going to kind of do the same things that we did in example 2, except one thing is going to be super different. So let's take a look at what's happening here in this scenario. It says the American Automobile Association, also known as AAA, claims that the average daily cost for meals and lodging for vacationing in Texas is less than the same average cost for vacationing in Virginia. The table at the left shows the results of a random survey of vacationers in each state. The two samples are independent. Okay, so we need to know that for this section of work. At a level significance of 0.01, is there enough evidence to support their claim, the AAA's claim here? Now, this one actually, it gives you the null and alternative hypothesis, so I won't waste time writing it down here. They gave you this little hint. Now, why did they pick this one, though, is a good question, which I want you to think about. The reason they picked, you're going to see right here, you have mu1 and mu2 from your first sample of Texas and your second sample of Virginia. Why did they pick greater than or equal to, and why did they pick less than? Well, that is because this little terminology right here, it says the claim is lodging in Texas, meals and lodging Texas is less than. So here's your less than symbol right here. Oh, that looks weird. I'm going to erase that because then it makes it look like it's less than or equal to. Bing. Look at that magic. But here's our less than symbol right here. We know that the less than, if it's by itself and not equal to, goes in the alternative hypotheses. We know that from our prior knowledge. And we have mu1 is greater than or equal to mu2 right here. Okay, and let's see, how are we going to get those things? Well, the first thing that we know is in our solution, we would write our null and alternative hypothesis, but it's already written, so I'm not going to waste our time writing that down. But we need to get that p-value. So I need what is my p-value going to be here? Well, in our last example, we showed how are we going to plug that into our calculators, and we're going to do that again right here. We need that p-value. All right, so where did we go before? We went to tests. We went down to 2 sample z-test, hit enter. It still has our data in from our last sample, but we need to put that in now. We need to put it in correctly. We need standard deviation 1, so that's going to be 15. Standard deviation 2 is going to be 22 doll hairs. The mean of sample 1 is 248. The sample size of example 1 is 50. Now you're going to notice these have different sample sizes, so that's interesting to note. I'm putting in mean of sample 2. We have our n of sample 2. I got to go down here. Now I got to choose less than right here. So I do need to hit less than, and then I need to hit calculate. And look at our p-value. It is going to be 0.175 in there, 0.175. And we're going to have to set it up, and we're going to do decision rule right here. Let me see if I can put it up before our little reminder comes up. It's versus 0.01, so 0.175 versus 0.01. What's going to happen with that? We know the alligator eats the larger number, so we are going to have a big giant greater than right here. And what does that mean for us? Well, we will conclude this problem in our next video, so stay tuned for that exciting conclusion. I want you to think about between this video, there's our little guy, between this video and the next video, what does this decision rule mean? What is it